right, here's our video on the second part of solving linear inequalities for the Algebra 1 Regents. 2D, we're still in the ocean. We got some waves going on here, right? So let's move on, right? So these are the symbols. We went over them last video. And we also talked about interval notation and set builder notation. So let's just concentrate on that for a minute here. Let's get our pen going. We got our little, let's start with red. Why not? So if we said, let's say we said 3 is less than m, we'll use m, why not? And we had something like this, right? So here we're saying m is greater than 3 but less than 15. So if we made a number line on that, making our number line straight as we can get it, we could put a 3 here, we could put a 15 there. Now, we're not going to circle in the 3 because m is not 3, it's greater than 3, and it's not 15, it's less than 15, so we didn't do any circles. We didn't fill in the circles, right? So there's our number line. And if we wanted to do interval notation, we would say we would put parentheses, 3 and 15. Now, you use parentheses when the variable doesn't include those numbers. So this is the minimum, this is the maximum, and m is not included because you have those parentheses. So it's anything in between those numbers. Now let me just change the pen there. If I gave you this, though, let's say we had this. We put m is less than or equal to 15. Then how do you think we would do interval notation? Well, we would do the same with the parentheses because it's not including 3. But we're including 15. M could be 15, so we use a bracket. So remember, we're going to either use braces or brackets for interval notation. All right, so let's clear that out. Rewind the tape if you need to. What if I had this? We're doing interval notation first. So if I said 15 is less than or equal to Q, which is less than, let's say 20. So how would we do interval notation? What do you think? Well, over here we have to use brackets because we're saying Q could be 15. So that's the minimum number we're using. And the max is 20, but we're not including the 20 because Q can't be 20 because you don't see that less than or equal inequality symbol. Now, for set builder, we're going to do this. Set builder usually works like this. We have our kind of a brace saying we're beginning our set. What are the numbers in this set? And we want to define the set before we show the numbers. So we're going to say Q, because we're using Q, is an element of something. And we use that Greek letter epsilon. It's an element of whatever you want that set to be. If you want that set to be just integers, you would say Z. Z is the symbol for integer. And you can put a positive there because you're saying that it's all positive integers. And then you have this line that says such that. This is the such that line. Right? It's, in other words, it's saying, well, what about it? What about that Q is an element of all positive integers? Because we're only using integers. So, and we'll say that, we'll just copy what we wrote before. This is set builder, and then close out the set. So whatever you want the set to define, how do you want to define the set? Using integers. Remember, integers, there's a Greek word, not Greek word, German word, Zahlen, which means number. And that's where they get the symbol Z. Sometimes they put another little line there. That's a bad one. Make it bigger. Sometimes they put another line. And then you can put plus or minus if you want to include that. Most of the time, you don't see the Z on the algebra regions. You'll see maybe N for natural numbers or maybe R for real numbers. So let me just clear that out again. Let's do another one. What if I said that -5 is less than, well, let's use G, right? And we had something like this. And we'll say that G is less than or equal to 30. So do interval notation. What would the interval notation be for that? And we'll change our pen. We use purple. Why not? Well, we're not including the -5, so we're going to use parentheses. And we're going to say -5. And that's our minimum number. Our maximum number is 30. But we're saying that G can be 30. It's less than or equal to 30, so we use brackets. So that's interval notation. Set builder, we would say this. We will say we'll make our set with our brace. We'll use G. And G is an element. In other words, all that G could possibly be. And let's say I said natural numbers. An element of natural numbers. Now that wouldn't make sense because negative numbers are not natural. So we can't use N. So again, natural numbers are just the natural numbers that you can count. 1 to infinity, to positive infinity, and beyond, right? So those are natural numbers, whereas whole numbers, begin with 0. That's the only difference. So we can't use N because we have a -5. So let's go find the eraser and get rid of that N because we can't use natural numbers. So instead, we can say integers, or we can say real numbers if you want to include decimals. And I'm going to say just integers, not a positive or negative there. Now, we're saying again, G is an element of integers. Such that, what about that? Such that, and then we just copy it over. Okay, and I'll talk more about set builder and interval notations again in other videos. Oh, and don't forget we have to close that out. Let's close it out. So that's interval notation, set builder notation. So let's solve some more inequalities. All right, let's get the pen going here. Why not? Let's use blue. Why not? And let's say I gave you -6x minus 17, and we said is greater or equal to, and let's say 8x plus 25. Why not? See if you can solve that problem. And again, remember these inequalities. Sometimes you see them like this, like I'm writing. Sometimes you see it like this. And very rarely you can see it with the line on top. You won't see that in the regions, but you may see that in high school sometime. All right, what do you think? So over here, we can get rid of the x's first or the constants first, whatever you want. And again, it doesn't matter which one you do first. You'll get the same answer. So let's change the color there. Let's get rid of the 17, at -17. I'll do the opposite operation. Whatever you do to one side, you do to the other side. Cross that out, bring down the -6x. Now we have -6x is greater or equal to 8x. And 25 plus 17. What's 25 plus 17? Right, so we got 42. Right, and don't go fast with this. You don't want to make a slight mistake here just from adding. That would be bad. All right, now we don't want to get rid of the -6x because that'll give us 0. We don't want that, so we're going to minus the 8x on both sides. Minus the 8x on both sides. And now we have a -14x is greater or equal to 42. Now, do not flip the signs yet. Remember the law, you flip the signs when you divide, right? Divide. We didn't divide. We subtracted so far. But now we're going to divide. We're going to divide the -14 on both sides. Whatever you do to one side, you do to the other. And then you'll know you have to flip it. That'll be your answer. Now you have to flip. So what do you think this would be? Okay, so now remember, we have a positive and a negative, so we're going to have a negative. 42 divided by 14 is 3. So that'll be our answer. X is less than or equal to -3. All right, let's add another one here. Use that color, right? We'll say, what if I had, let's do a distributive property one. Let's say I had 3 2m minus 1 is less than or equal to 4m plus 7. So we got to distribute first. Remember, distribute. And we use a different color, green. So we're going to have 3 times 2m, which is going to give us 6m. 3 times -1 is going to give us -3. And is less than or equal to 4m plus 7. And the same thing. Let's get rid of the 3. Again, you could have got rid of the 7. Remember, we're adding it. We're doing the opposite operation. Now we have 6m is less than or equal to 4m plus 10. And what's the next step? What do you think? Well, let's get rid of the 4m. Right? We have to do one side, do to the other, right? And now we're going to have 2m is less than or equal to 10. Divide out the 2 on both sides. Now this time we're not flipping because we have no negatives, right? We have no negatives, so we just keep it the same. 10 divided by 2 is 5. And there's our answer. Now let's do one more. Okay, and go back if you have to, but you know that, right? And what if I had a negative 4, and we did a little parentheses, 2m minus 6, and then we said plus m is greater than 3m plus 4. So why don't you pause the tape and do that one? So again, we have to distribute. So we'll distribute the 4. So now we're going to get negative 8m plus 24. Right? Be careful. It's negative times a negative is positive. Plus m is greater than 3m plus 4. Make sure you clear this out. We have a negative 8m and we have an m. So that's going to give us negative 7m. Remember, combined like terms you should be familiar with. And if you're not familiar with, there's other videos I have on those. Just remember, you're just thinking of negative m plus 1. Remember, there's always a 1 next to a variable. Right? And if you owe $8, but someone gives you $1, then now you owe $7, right? So let's get rid of the 4. Usually I always get rid of the smaller numbers, but it doesn't matter. Whatever you do to one side, do to the other. Right? And you can make the 4s any way you want. So over here I made the 4 like that, but I made the 4 different over there. It doesn't matter, right? So I have a negative 7m plus 20 is greater than 3m. And always double check. Slow down if you need to. Let's use that color right there. All right, so now let's get rid of the 7m by adding it on both sides, right? I'm adding the 7m on both sides, and let's bring this arrow so we can finish it over here. So that cancels out, and we're left with 20 is greater than 10m. And we just divide the m on the 10, not the m, and we're having that 2 is greater than m. 2 is greater than m. Let's do one. I said just one more, but let's do another one. Why not? Let's do one with just the inequality. And tell me what type of graph you get. So let's clear that out. Let's say I had, what kind of graph would you get for 2x minus 5 is less than 3? What kind of graph do you think you would get? Try that. You'll see those questions on the regions. Well, first of all, let's add the 5 on both sides. And we're going to get 2x is greater than 8. And we know that x is less than 4. So our graph should show that x is less than 4. Should have a 4 there. And we do not circle it in because it is not equal to 4. It's less than 4, and it's going that way. All right. So that is solving inequalities part 2. And we're going to do compound inequalities in the next video. So I think we did a good job today. Let's clear that out. I'm sure you did a great job, right? We'll put a little sticker there. We'll put a couple of firecrackers. Why not? Or whatever these things are. All right. Great job.